All right, today we're going to be talking about our practice test slash review for the Unit 1 test over factoring, properties of exponents, multiplying, dividing, adding, and subtracting rational expressions. Okay? So this first one right here, I always look for GCF when I'm factoring. It says just factor expression. If not factorable, just write NF. Okay? So I see three terms here, no GCF. So I'm going to go ahead and I'm going to try star method here. So A times C is a negative 20. B is a negative 1. A, 1, and 1. Two numbers that multiply to give me negative 20 that add to equal negative 1 are going to be a negative 5, positive 4. So then now I just look at my fractions here. Negative 5 over 1 gives you x minus 5. 4 over 1 gives you x plus 4. Okay. Again, number 2, no GCF here between the two, so three terms. I think star method every time. Okay, A times C, 9 times 1 is 9. B is 6, A is 9, and 9. So two numbers that multiply to give me 9 that add to equal 6 are going to be 3 and 3. So now we have fractions here that don't simplify down into nice whole numbers. So you end up having x plus 1/3, which is 3/9 reduced, times x plus 1/3. And now whenever you have a fraction, you have to kick the denominator in front. And so my factors are going to be 3x plus 1 times 3x plus 1. Okay? All right, on to number 3 here. Okay, 3x squared minus 108. Okay, they do have a GCF there. They have a GCF of 3. And so when I do that, I'm going to be left with this. I'm going to have 3 on the outside. Okay, and then left in the inside of the parentheses there, 3x squared divided by 3 is just x squared. Okay, and then 108 divided by 3, I'm pretty sure is 16. No, I'm sorry. That's not 16, it's 36. Now, in most cases, when we take out a GCF, there's more we can do inside the parentheses. What I see right here is I see two terms, minus sign. Remember what I said? I said whenever the exponent is either to the second or to the fourth power, it is always a difference or sum of two squares. This is dots. Okay, dots factors down to be this. So bring the 3 outside, x plus some value, x minus some value. Okay, and how do we find that value? We just take the square root of 36, which is 6. And there you go. So your answer is going to be 3 times x plus 6. Please do not forget about the 3 that you took out to be in the GCF, okay? All right, 64x to the third plus 125, okay? First things first is there's no GCF between the two, but then I see this 3 here at the exponent. So this is either a dox or sox. It's a sum of squares or a difference of squares. Because this plus sign, it's a sum of squares. So the first thing I have to do is, okay, and recall our formula for sum of squares. Remember, same, opposite, always positive for your sign. So anyways, first things first is I need to find A and B. To find A, I take the cube root of 64, which is 4, and the cube root of x to the third, which is x. So A is equal to 4x. B, same thing. I just take the cube root of this second term here, the cube root of 125 is 5. And now all I do is just plug it into my formula here. So I'm going to have 4x plus 5 times a squared. So if a is equal to 4x, remember you got to square both. So 4 squared is 16, x squared. Opposite sign, so a times b, 4x times 5 is 20x. Always positive, plus b squared, which is 25. And there you go. So there's your, and the nice thing too, which I know it's a little bit more difficult, but when you get to sum and differences of cubes, you cannot factor this trinomial down anymore. So you are done after you do that. Okay? 5 terms here. Okay, 5 terms. Not 5 terms, sorry, 4 terms. Okay? First off, we look to see if there's a GCF between any of these, and there's not, so I'm going to automatically go ahead here and just do factor by grouping. Okay, so I group both of them, drawing like a little line down the middle to separate them, and now I just focus on the left side here. What do they have in common? Looks like x squared. And so when I do that, it's going to leave x squared on the outside, and that's going to leave me now with x, not x, sorry guys, 2x minus 3. Okay, and then when I look at this right side here, I try to, it looks like, because the only thing they have in common is a 1, but that's a negative in front of the x, I'm going to factor out a negative 1. And so I do that, I do negative 1 out front, that leaves me with x minus 2. Okay, big problem here is that when you're doing factor by grouping, you have to have common expressions here. 2x minus 3 does not equal x minus 2. And so we cannot factor that. Okay. Now I know this looks a little bit more difficult, okay? But really it's not. This is still, we're going to still treat this like a trinomial, like original star method. Okay? And so let's do that. So I'm going to do a times c, so that's a negative 9. b is 8. a 1 and 1, so I need 2 numbers that multiply to give me a negative 9 that add to equal 8. And so that's going to be 9 and a negative 1. Now, when we write our factors out, normally, if you remember from this first problem up here, right, it's always just x and x because it's x squared. Well, now all we did is we just changed it to the fourth. So instead of it being x and x, it's now going to be x squared plus 9, x squared minus 1. Now, I'm going to bring it up here. There's more we can do. Okay? We now have sots times dots. So sots is in the form of x plus something with I on the end, x minus something with I on the end. How do we find that minus? Well, or how do we find what's next to the I there? Just take the square root of 9, which is equal to what? 3. So we got x plus 3 times x minus 3. And then the dots, we already know, guys. This breaks down to be, we've already seen x plus 1 times x minus 1. So then it's going to be hard to write this all in the box here, but your final answer is going to be x plus 3i, x minus 3i, times x plus 1 times x minus 1. Okay, and recall, okay, sums always has i's, sum of squares. Sum of squares always yield i's, okay? All right, that's it for the just factoring session. So now we're going to go ahead and simplify. So, when I see a problem like this, okay, what I like to do is, since we just have a monomial, I go ahead and I just multiply across. So 15 times 6 is 90, and now we add the exponents when we multiply like bases. So 2 plus 3 is going to give you x to the 5th. Y and y to the 2nd is going to give you y to the 3rd. Remember, that's like having a 1 there. 1 plus 2 is 3. All over, denominator here, 6 times 5, 30. X to the 4th plus x to the first is x to the fifth. Y to the fifth, y to the first is going to give you y to the sixth. Now let's just go ahead and simplify. So 90 over 30 is like saying 3 over 1. I have 5 x's in the numerator, 5 in the denominator, so therefore they cancel each other out. So that's gone, that's gone. Okay? And then I have 3 y's in the numerator, 3 in the denominator. 3 y's in the numerator, 6 in the denominator. So I can equally take away 3 from each. So that goes away, and then you're just left with y to the third, and so your final answer is 3 over y to the third. Okay, so this next one we didn't really have notes on, so just really kind of pay attention here. We're going to break this down, prime factorization, right? Okay. So when I break down 54, that's 27 and 2. 27 breaks down to 3 and 9. 9 breaks down to 3 and 3. Now, because this is a third root, the only way I can bring stuff outside is finding groups of 3. Finding groups of 3, okay? So I want to look at the variables as well. I'm going to write them out. So over here, I'm going to write out x times x times x. The y's I'm going to write out is y times y times y. So that's 7 y's there. And then the z's as well. Okay, and now all I'm doing is I'm looking for groups of 3. Okay, when you look at the 54, you want prime factorization. So like 1, 2, 3, 5, 7, numbers that are prime. Okay, so anytime I find a group of 3, I can bring 1 out. Okay, so look at this. So right here is a group of 3. Okay, so 3 times 3 times 3, so I can bring a 3 out front. Okay, and then whatever is left over, this 2, I'm going to square, and that's going to remind me to go back underneath our root sign. Okay, I have one group of x, so I can bring out an x down here. I have 2 groups of y, so 1, 2, so that means y squared, because I have 2 groups, 1 y for each, you multiply them together. And then what is left over? A y, which I'll square, which tells me it goes back on the root sign. Then I look at z's. I have 1 group, 2 groups, 3 groups. So that is z to the third. Okay, with 1 z going back under. So now I draw my root sign. Don't forget about the 3 up here. Okay. Try not to make that z to the third closer. When I rewrite the answer, I'll space it out. Now, what goes back under? Everything squared. So 2yz. So when I write out the final answer, it's going to look like this. You're going to have 3x y squared z to the third times the third root of 2yz. Okay? All right. Number 9 here, okay? So we've got a fraction here, all raised to the second power. So here's what I want to do. First thing I want to do first is I'm going to go ahead and distribute Well, let's simplify with what we can simplify in the parentheses. So 3 over 12, what does that simplify to? 1 over 4, so 1 over 4. If I have 1x in the numerator and half in the denominator, okay, how many can I equally take away from both there? Just a half. So that's going to leave me with x to the 1/2 up here. Now, can't have a negative exponent. So that y comes down here, and so now it's y times y down here. This has got to move to the denominator. It's got to move to the denominator because it's negative, and so then now you have this. You have 1 over 4 x to the 1/2 over y squared, all raised to the second power. Now I've got a power raised to multiple powers here, so I've got to distribute this power to each term. So there to the 1/2, there to the 1, to the y, and then also to the 4. So it's going to look something like this. It's going to be 1 to the second power times x to the 1/2 times 2. 1/2 times 2 is just 1, so it's just going to be x all over 4 squared. And then power raised to power, you multiply, y to the 4th. And so then our final answer is going to be this. 1 squared is 1 x over 4 squared, which is 16 y to the 4th, and there's our final answer. So 1 over x. So you could, if you don't want to have to write the 1, you don't have to, but 1x over 16 y to the 4th. Okay, for this one, I really just want you to have the understanding of how to write it in radical form. I don't really care. It's going to be really hard to simplify. So just remember, so we go from exponential expression to a radical expression. It just looks like this. Okay? We're going to do, sorry, give me a second here. I apologize. Yeah, so let's do this. So we're going to go ahead, we're going to distribute this 3/4 to every term there. So now it's going to look like this. So I'm going to have 81 to the 3/4. X to the 2 times 3/4 there, so 3 over 2. Actually, yeah, here's how I want it. Sorry, that's my fault, guys. Just rewrite it like this. I just want it like this. That 3 to the 4th, okay, we write that with a radical. It's just going to look like this. Remember, the denominator goes to the root. Okay, so we're just going to have this. We're just going to have 81x to the second power over y, all raised to the third power. There you go. You're just rewriting it. Okay, you're just rewriting it. Okay, that's all I want to see. So that's your final answer right there. Okay, so you're just rewriting it from exponential expression 2. So the denominator goes to the root, the numerator goes to the power, everything goes under the square root sign. Okay? All right, simplifying here. Okay, simplifying here. So we've got 3x to the third minus 21x squared plus 18x. So let's look at, so we got some factoring we can do here. So in the numerator here, it looks like I can take out a 3x. So when I do that, that's going to leave me with x squared minus 7x plus 6 all over. Factoring here, what can I do here? I can take out a 3x. And so then I'm left with just x minus 1. So now let's just go ahead and get this out of the way, cancel those 3x's out, and so now you're left with just this trinomial over this binomial here, which, let's go star method here. A times c, so a times c is 6, b negative 7, 1, and 1. I need two numbers that multiply to give me 6 that add equal negative 7. That's going to be negative 6 and negative 1. And so then this trinomial is going to factor out to be like this. It's going to be x minus 6 times x minus 1 all over x minus 1 cross those out, and so you're just going to be left with x minus 6 because they have a common expression there. Okay, so this one looks a little tricky here. What we're going to do is we need to get a common denominator here. Remember, we've got two rational expressions adding together. Remember what I said in class. Whenever you can factor that, okay, whenever you can factor one of the denominators, that will always be your common denominator. So x squared minus 2x minus 3 factors down to be x minus 3 times x plus 1. So when we're just looking at the denominator here now, that gives me 2 over x plus 1, which when I want a common denominator, I need to have my denominator look like this denominator here. So I already have the x plus 1, but I don't have the x minus 3. So I'm going to go ahead and multiply top and bottom by x minus 3. Okay? Plus x over, already my common denominator, x minus x plus 1 times x minus 3. So now after I do that, all together, you got to distribute this 2 here to the x and to the negative 3. And so it's going to give you 2x minus 6 plus x all over x plus 1, x minus 3. So that's going to be what? 3x minus 6 over x plus 1, x minus 3. Okay? So now that's just my denominator, okay? That's just my denominator. So now, when you see this form like this, where you see 1 over 2x minus 2, that's the same thing as this, guys. It's like saying this. It's like 1 over 2x squared minus 2 divided by 3x minus 6 over x plus 1, x minus 3. That's all that is. So we have to keep, change, flip, and I'm already going to start factoring out because I'm running out of room here. So 2x squared minus 2, you factor out a 2 there, that gives you x minus 1 to the second power. Change to multiplication and flip here. X plus 1, x minus 3, all over factoring out a 3, which then would give you x minus 2. Now I can factor a little bit more here with this 1 over 2 times x minus 1. That's a difference of squares there. And so that gives me 1 over 2 times x plus 1 x minus 1 times So you got x plus 1 times x minus 3 all over 3 times x minus 2. So really, there's not a lot we can really do here. We can cross out the x plus 1s. And then it looks like I'm going to be left with this. So in the numerator, it's not bad. It's just x minus 3. In the denominator, I'm going to be left with 2 times 3, which is 6. And then I have 2 binomials left over, x minus 1, x minus 2. So that was a little crazy. We had to get one rational expression here by adding these two together, which is what I did by finding the common denominator between the two, which whenever you factor a denominator, that is your common denominator, and then getting the same common denominator here, which I end up finding to be 3x minus 6. That was my one rational expression from adding this together. I then took this rational expression divided by this rational expression. I know that's a little crazy, okay? All right, couple more to go here, Here we go, okay? Perform the indicated operation. So it looks like multiplication here, okay? So multiplication, I always put this over 1 because, again, I'm supposed to be multiplying two rational expressions having a numerator and a denominator. So I write that over 1. So now here we go. We go ahead and factor what we can. The x plus 4 doesn't change. Again, two terms minus sign 25. We've seen this so many times. This is a difference of two squares. So that factors down to be x plus 5, x minus 5, all times. I've got a trinomial here. Okay, trinomial with no GCF, so I just think star method. So two numbers that multiply to give me negative 10 that add to equal 3. So two numbers that multiply to give you negative 10 that add to equal 3 are going to be x plus 5, x minus 2, all over 1. Nothing else I can do, so I'm going to go ahead here and I'm going to cross out any common expressions, which it looks like just the x plus 5s. And so then multiply across, so it looks like our final answer is just going to be x minus 4 x plus 4, times x minus 2. All over x minus 5. And there you go. Okay, next one here looks like we got division. So remember, keep, change, flip, right? Keep, change, flip. So I've got 4x minus 8 over x squared minus 3x plus 2. Change to multiplication. Okay, and then flip the second fraction. So x minus 1 over 3x minus 6. I then now go ahead and I need to factor. So I look at this first rational expression here. This 4x minus 8, I can take a GCF out of 4 out, and that's going to leave you with x minus 2. All over x squared minus 2x minus 3x plus 2. That's a trinomial star method. So I need two numbers that multiply to give you two that add to equal negative 3. And that's going to be x minus 3. Or I'm sorry. Not x minus 3, x minus 2, x minus 1, times, thankfully there's nothing I can do to this x minus 1, it's just a binomial, down as simplified as possible. And then this 3x minus 6 looks like I can take a GCF of a 3 out, which then gives you x minus 2. Now we've got a bunch of common expressions here. The x minus 2's go away. The x minus 1's go away. And so you're left with this, just a 4 in the numerator over 3 times x minus 2. Okay. addition here. So biggest thing I notice here is, again, with addition and subtraction, I want a common denominator. Biggest thing I notice is that this denominator can factor here, and it actually factors down to be two numbers that give me 21 that add to equal negative 10 are going to be x minus 7, x minus 3. So whenever you're able to factor one of the denominators, guys, that is always going to be your common denominator, at least in this case here. So that's our least common denominator here. Okay, it's our least common denominator. So my goal is to get this and this to equal this. Now this right here already equals this, so I don't have to do a lot of work. So for my first fraction here, first rational expression here, there's nothing I need to do. I leave it as x minus 7, x minus 3. Okay? All right? Plus now, because the plus sign, 5 over x minus 3, which, again, when you look at your LCD, you have part of it already. You just need to multiply top and bottom by the part that you're missing. And I'm missing x minus 7. So I'm going to go times x minus 7 times x minus 7. And here we go. So you're going to have this. You're going to have 3x, okay, plus this 5 gets distributed to the x and then to the negative 7. So 5x minus 35 all over x minus 7 times x minus 3. Combine like terms here, and that's going to give you 8x minus 35 all over x minus 7 times x minus 3. There's nothing I can do to factor anything out of the top here, so your final answer is just going to be 8x minus 35 over x minus 7 times x minus 3. Okay, 16 here, okay, so we talked about this today in class, okay. Whenever your two denominators are just binomials that can't be factored at all, the only way you can get the LCD is by multiplying them together. So my LCD then is just going to be this. It's just going to be x minus 2 times x plus 1. Okay? So what that means is that I need to go and I need to change both of these denominators to this. So that x minus 1 over x minus 2, I say to myself, okay, I have the x minus 2 already in the denominator from the original problem, but I need the x plus 1 as well. So I go ahead and multiply top and bottom by x plus 1. This now becomes a plus. And remember, whenever you have a subtraction sign, you distribute that to both terms, to the x and to the negative 4. So now I'm going to have this. So I'm going to have a negative x plus 4, okay, over x plus 1. Now again, I'm trying to get this denominator to look exactly this. So I'll multiply the top and the denominator and the numerator by what I'm missing. I'm missing that x minus 2 from this. Okay? Now there's going to be a lot going on here because now what am I doing? I'm foiling. I'm foiling here. Okay, I am foiling. So I'm going to get this in the numerator up here. X squared plus 1x minus 1x minus 1. Okay. Negative x times x is a negative x squared. Negative x times a negative 2 is a positive 2x. 4 times x is 4x. And then 4 times a negative 2 is a negative 8. Now I know that looks a little crazy, okay, but let's go ahead here now. This is all over okay. Now let's combine like terms here to get our final answer here. So it looks like this. We looked at it looks like the x squareds cancel out because you've got a positive x squared, negative x squared, so I'm going to cancel them out. I've got 1 minus 1, so these are gone as well. And then it looks like I'm just left with 2x. Looks like I'm just left with 2x and 4x there. So it looks like I'm left with 6x. And then negative 1, negative 8. So it looks like I'm just left with 6x minus 9 over x minus 2, x plus 1. Which again, we can simplify the top a little bit. You can take out a 3 there. And so that's going to leave you with 2x. Because 6x divided by 3 is 2x. Minus 9 divided by 3 is 3. All over sorry, I have no idea why I made that a k. That should be an x. Okay, this next one here. Before I even think about a least common denominator, I want to go ahead and factor and see if I can simplify these rational expressions one bit at all here. Okay, so 6k over 3, that can be simplified, right? Because that's a monomial over a monomial. What is 6 over 3? Just 2 over 1. Okay, minus 6 over, I can factor out a 2 here. 2k plus 4, which then look what happens here too. What is 6 over 2? 3. So now look what my new problem looks like. It's going to look like this. It's going to be 2k over 1 minus 3 over k plus 4. So this looks so much easier now, so much easier. So my LCD, I've got a monomial times a binomial. The only way you can even come up with an LCD for that is just by multiplying them together. So then your LCD is just k plus 4. Okay, just k plus 4. So now I need to go about changing both of these denominators to k plus 4. So when I look at this first one here, okay, 2k over 1, well, the only way I can get this 1 to be a k plus 4 is to multiply top and bottom by k plus 4. Okay, this now becomes a plus because this minus sign is being distributed to that 3. So negative 3 over k plus 4, which is nice. I don't have to do anything to this part right here because it already has my least common denominator of k plus 4. So that's nice. So I just got to make sure to remember that anything to the right of the minus sign in the numerator, the sign changes. So that minus sign gets distributed to that and is replaced with a plus sign. So now we need to go ahead and just simplify. So I'm going to do 2k times k, which is 2k squared. 2k times 4 is 8k. Okay. And then just bring down the negative 3. 3 all over k plus 4. Now, we normally should check to see if we can factor this, which I will. I'll check right here, star method. So 2 times negative 3 is a negative 6. B is 8. And so I'm trying to think of two numbers that multiply to give me a negative 6 that had to equal 8. And it's just not possible. So therefore we know that can't be factored anymore. And so there you go. That's my final answer there. So my final answer is going to be 2k squared plus 8k minus 3 over k plus 4. And there you go. All right, last one here. Last one. Factor completely. Factor completely. Okay? So, first things first is we need to look for a GCF. Do these all have a GCF? They do. Okay, they are all divisible by 4x. So I'm going to do brackets. I'm going to do a bracket around this one. Okay, so I factor out that 4x. That's going to leave me with x to the 4th. Negative 16 divided by 4 is a negative 4. That's going to leave me with x squared. 8x to the 3rd divided by 4x. That's going to leave me with a plus 2x squared. And then negative 32 divided by 4 is a negative 8. The x's cancel out. I wonder if that's a typo or not. Maybe so, I'm not 100% sure. Sorry about that. Alright, we'll just keep going what we're doing here. It should still work. Okay, so let's go ahead and let's group now. So I'm grouping these two and these two. And so drawing a line down the middle here, I'll bring back the 4x in a little bit. So what do these two have in common? They have an x squared. So that's going to leave me with x squared times x squared minus 4. Okay. Factor out the 2 here and the second one. What do they have in common? It just looks like a 2. And so then that's going to leave me with minus 4. And so now we have something that looks like this. So let's come in and bring our factors together. So we bring down, because we have common expressions here, we bring down 1x squared minus 4. You also bring down your GCFs here of x squared plus 2, and then don't forget about your 4x. Now, I would love to say we're finished, okay? And we talked about this real briefly, but this is SOTS here, but this is not a perfect square. If you were to take the square root of 2, you would get the square root of 2, okay? You do not need to try and factor this down more. Now this here, though, is the nice dots. These are both perfect squares. So recall, this factors down to be x plus, x minus, square root of 4 is 2 and 2. And so our final answer, just bring these down, is going to be this. It's 4x times x squared plus 2 times x plus 2 times x minus 2. And there you go.